Thank you, Simon. Namaste, all the participants and the speakers. Thank you for giving me this opportunity. So before starting my presentation, I pose a question. Why Artemia usage in shrimp hatchery? Reason? Because of its high nutritional content, UFA. This is mostly subsists on the yolk. And second thing is, this Artemia is a preferred prey for the shrimp larvae. And third most thing is, more intrinsically, most of the crustaceans have the cannibalistic nature. To satisfy the cannibalism, we can give the Artemia as a preferred prey. So coming to the Indian status of hatcheries, we have total number of hatcheries are 401. Out of that, 2 hatcheries are for SPF P-monad hatchery. Rest all hatcheries are permitted to produce L1MI seed production. And the total brood stock imported in the 2020 around 2,50,000 brood stock. Next slide. So coming to our Indian history of the shrimp hatchery operation, in the before 1988, we have no commercial hatchery. After that, Empire established one hatchery in Tass Park, that is in Visakhapatnam coast, one in Ose Park, that is in Gopalpur. Before that, most of the farmers are dependent on the wild seed. That time, there is no use of using Artemia. After establishing these commercial hatcheries, and they mentored and extended their technology for many of the private hatcheries. Now, India is one of the largest producer of shrimp sheep and one of the largest producer of farmed one shrimp. So last year in the 2020, we have produced 70 billions of shrimp feed and 30% considered as a bonus. The total gross production, if you consider it, is around 90 billions. Because farmers, while transporting, they have some mortality. To compensate the transport mortality and acclimatization mortality, normally this is a practice up to 20 to 30% are given to the farmers in addition to the net amount. Estimated Artemia consumption is around 325 to 350 metric tons per annum altogether. And feeding Artemia starts from Joya 3 onwards. Most of the Artemia source is coming from Great Salt Lake, Utah, GSL. A number of feedings depend from hatchery to hatchery and technician. It's almost around 3 to 5 numbers. Average Artemia consumption per million is almost 3.5 to 4 kgs, on an average 3.8 kgs. Next is, this is the typical hatchery setup in the Indian system. Most of the hatcheries are having roof lighting system to enhance the illumination, and above the 30 centimeters above the surface of the hatching tank, they have the illumination. Some hatcheries are only having without any natural this thing. Some hatcheries are following only artificial illumination around 2,000 to 3,000 lux. So next slide, please. So source, most of the people hatching process, most of the people are selected the GSM.
Vũ ơi, em bây giờ mình có
GSL is a preferred product because of its ease of use and consistency. And the average hatching percentage considers more than 80% because Indian people, more hatching means consider more quality. And bacterial loads also less preferred. And color of the Artemia biomass is preferred mostly orange. That is, it indicates the rich pigmentation. Next slide, please. And the decapsulation and the disinfection. Most of the hatcheries are following the disinfection procedure up to 5 minutes. Usually all the Artemia cans are coming in 425 grams to 454 grams. So before disinfection, 20 liters of water taken, clean seawater, and 2000 ppm of bleaching powder are used for up to 5 minutes. Decapsulation, disinfection. For disinfection purpose, bleaching, liquid chlorine, formaldehyde, chlorine dioxide, iodine are being used. For decapsulation, some hatcheries are following decapsulation. That is up to 15 to 20 minutes. Bleaching powder and the liquid chlorine are being used regularly. To remove the chemicals, thorough rinsing of the cyst after decapsulation is very much required. Any traces will hamper the hatching. This is the various process of decapsulation and disinfection. Next slide. Hatching. Coming to the hatching tanks are cylindrical tanks and 500 liter capacity. cylindrical shape, and bottom we have a translucent conical shape bottom, and with a tap valve to control the water flow. And PVC standpipe is being used in the center in order to prevent the trapping of the cyst accumulated in the center of the dead corner. Stocking density usually we go for 1 gram per liter. And here the most important point is filtered and most sterile seawater is being used for the hatching. If the water itself is contaminated after hatching starts, Artemia hatching, a lot of Vibrio loads we can find. That's why this is filtered and very much sterile, clean seawater is very much required. And further 1000 to 2000 lux of lighting illumination, artificial illumination is provided above 30 centimeters of the surface of the hatchery. Oxygen supply, continuous oxygen supply is provided to suspend the Artemia cyst, and temperature 28 to 32 degrees is being maintained. And periodical wiping is very much important because once the cysts are hydrated, they tend to cling to the surface, peripheral surface of the tank. Once they settle onto the surface, the suspension is reduced and hatching percentage is also affected. That's why periodical wiping and stirring is very much important. Additionally, probiotics, depending upon the spore count, 5 to 20 ppm, chlorine dioxide 2 to 5 ppm, ozone 300 to 350 ORP, infusing into the hatching fluid, significantly reducing the bacterial loads and slightly improving the hatching percentage. Next slide. Coming to the harvesting. Before harvesting, this is the typical Artemia section with conical bottom with the 4 legs. This is the clean seawater. This is the incubation setup. This is the vigorous aeration. Next slide. Coming to the harvesting, it requires a lot of skill and a lot of patience also. So in order to get the maximum output from the hydrated cysts, before going for the hatching, so we need to stop the aeration and remove the standpipe. Once we remove the standpipe, the cysts are separated into 3 parts. One is empty shell, one is hatched out freshly embryo, and the third one is the unhatched cyst. Unhatched cysts have the more weight, because that's why it settles into the conical bottom. And this all the empty shells coming to the surface because they are lightweight. And all the freshly hatched out Artemia suspend in the water column. Next slide, please. So before commencing the harvesting, we need to completely darken the surface in order to prevent the photoactivity of the nauple towards the surface. Here, as we discussed earlier, conical bottom is there in the bottom of the Artemia tank. Here, additionally, we are providing the lighting to attract the Artemia nauple as soon as possible, because here there is no aeration, oxygen problem might happen, and nauple also will get affected. That's why we provide the additional lighting to attract the Artemia nauple as soon as possible. Once the Artemia cyst is removed, unhatched cyst is removed, then the Artemia nauple starts coming out. Then we will go for the 2C method. This is one is the 180 micron. This under one is the 100 micron. So Artemia hatched out, all Artemia can pass through the 180 micron. All the unhatched cysts retain in the 180 micron. This 100 micron is to collect the passed out Artemia nauple. Once Artemia is coming into the 100 micron net, it is thoroughly rinsing with the clean seawater to get rid of all the hatching fluids, bacteria, whatever it is. Only clean nauple retains. After getting the clean nauple, Artemia nauple, we go for biomass weighing and hatching percentage. Once it is confirmed, then it is holding for the feeding. Next slide. This is post-harvest handling. Artemia nauple are inoculated with some probiotics in order to reduce the bacterial loads. Depending upon the spore count and mode of action, we prefer 10 to 20 ppm of probiotics. And recently, some people are using bacteriophages. So they are mostly affect on the Vibrio control, that is 5 to 10 ppm. And some people are treating with the powdered iodine, 20 to 30 ppm to reduce or control the bacterial loads. For Zoea and mycetase especially, they cannot catch the active and agile Artemia nauple. That's why we need to inactivate. For that, either we need to choose the heat inactivation or killing or frozen. So some people are following heat inactivation, some people are following frozen. For heat inactivation, 100-degree boiled hot water, to ensure biosecurity. If there is any bacteria is there, that also can be reduced, and the proper inactivation of the Artemia and stored in the -20 degrees. From post-larva onwards, live Artemia are fed directly from the holding tanks at room temperature. Sometimes some people are using this enrichment with micronutrients like vitamin, mineral, and amino acid mix and probiotics to complement the existing Artemia apply. Next slide, please. Conditions influencing the Artemia hatching output. Most crucial parameters are temperature. High temperature fluctuations between day and night. Since the tanks are very small, we cannot establish the individual thermal control. It is cost effective for the operator. That's why we depend on the natural temperature. Especially in the winter season, diurnal fluctuation is very more. That is impacting the hatching percentage. Sometimes light fluctuating in the day and night situation. Some daytime, some people are using daylight along with the natural artificial light. Some people only depending upon the artificial light. So that's why lighting fluctuation is also observed, and control of the pH also. As the hatching is proceeding, some pH fluctuations are observed. And biosecurity, biggest threat in the Vanami hatchery is the for any other regions. This is a Vibrio. So in order to avoid that Vibrio, we need to take utmost precautions before hatching and after hatching also. Hatchery technicians, availability of the skilled labor, because it requires a lot of skill and patience. So this is one of the problem are considering. Next slide. This is Artemia feeding to the rearing tank, the LRT. This is a total feeding we can divide based on the size and age of the post larvae, and the daily ration will be divided into the daily number of feeds. This is mostly preferred in the alternative feeding. One feed, particulated feed followed by the Artemia feeding in order to improve the larval quality and digestive capacity. This is the freshly harvested, freshly fed larvae. This is normal. Next slide, please. Thank you very much, sir. And before concluding, I need to give few things, sir. This Artemia, live Artemia is agile and improves the seed quality and the robustness of the overall seed quality, because Artemia is very active when compared to the shrimp larvae. In order to catch that Artemia apply, that larvae tend to swim very fast. By that nature, that Artemia, this shrimp seed becomes very robust and the overall quality also improves. Recent developments of using chlorine dioxide, some people are using ozone, some people are hydrogen peroxide, reduces the bacterial loads in the hatching tanks and slightly improving the hatching also. So timely feeding to conserve the maximum yolk reserve is the main consideration. And one more point is responsible use of the limited and the natural resource of this Artemia by using the latest techniques and good care to improve the hatching efficiency. And most of the people, after getting the 80% of the hatching, 20% unhatched cysts are discarding. For that also, we need to take some protocol to better utilize the total Artemia biomass. Thank you very much. Thank you for giving me this opportunity.